IBESS, Atmospheric Systems and Pollution Management Part 10, is the last of this unit. This movie, Part 10, has its focus on DDT, an insecticide that has aroused controversy. Here is the outline of all the movies available for the Atmospheric Systems and Pollution Management unit. Use this slide to find the movie you need for review. This movie is focused here on DDT. Here are the IB syllabus statements that drive this movie. Describe the anti-malarial and agricultural use of DDT. Evaluate the uses of DDT. And dichloro-diphenyl trichloroethane, DDT, exemplifies a conflict between the utility of a pollutant and its effect on the environment. DDT was developed after the Second World War as a pesticide to kill insects that infected crops and as a pesticide to kill mosquitoes. Here is the molecular structure of DDT. DDT's insecticidal properties were discovered in 1939. DDT was used in the second half of the Second World War to control malaria and typhus among civilians and troops. In this photograph, DDT is being sprayed on crops to reduce pests that would reduce agricultural productivity. Remember, DDT was initially used in agriculture to kill insects that infected crops. DDT was developed after the Second World War to kill pests that reduced agricultural productivity, including pests that infected animals. Here is an image of DDT being sprayed onto a lake that would breed mosquitoes. Now, malaria is a disease in human societies caused by a one-celled organism that is spread by mosquitoes when mosquitoes bite. Malaria is spread by mosquitoes. DDT has been found to be effective in reducing deaths due to malaria, but DDT has been more effective in some locations than others. You can see in these data the number of deaths due to malaria decreased significantly in Southeast Asia shortly after DDT was introduced to the world in the 1940s, early 1940s. But deaths in Africa did not decrease with the arrival of DDT in the 1940s. In Brazil, during a time when DDT was being sprayed in household, cases of malaria were less than after DDT was stopped being sprayed in those households. Once DDT spraying stopped, malarial cases increased. But even as early as 1945, people were beginning to warn against DDT, capable of considerable damage to wildlife, to beneficial insects, and indirectly to crops. But, as this Department of the Interior memo suggests, knowledge was incomplete of the full effects of DDT. As the Second World War came to an end, there was an economic and technological boom, and DDT was viewed quite positively. DDT, along with televisions, air conditioners, and toasters, was part of a technological and economic euphoria that followed the end of the Second World War. But by 1962, Silent Spring by Rachel Carson had been published. Carson speculated that DDT, an insecticide used on farm fields, had entered the human food chain, causing cancer. Silent Spring was on the crest of a wave of environmental awareness and a new environmental politics. The developed world, the MEDCs, became alarmed about DDT, and soon there was sufficient political interest in banning DDT. DDT was banned from use in the U.S. in 1972. And by the late 1970s, levels of DDT in breast milk among Swedish women was seen to be declining, supporting the suggestion that DDT had been accumulating in tissues and had been magnifying up the food chain. Sweden had banned DDT in 1969. There is evidence that DDT, or a derivative of DDT known as DDE, accumulates in the fatty tissues of animals. This is known as bioaccumulation. Once in the tissues of organisms in the lower trophic levels, the toxin magnifies up the food chain. This is a concept familiar to you, and you should be able to distinguish bioaccumulation from biomagnification. And here is a relevant IB syllabus statement. The impact of pollutants on organisms or environments may take time. Once released into the environment, there may be a time lag before an appreciable effect on organisms is evident. This graph shows eggshell thickness on the y-axis over time on the x-axis in peregrine falcons. And there is a strong correlation between the introduction of DDT and a thinning of eggshells in raptors. The thinning eggshells interfered with successful reproduction, causing the bird populations to decline. Again, here is a strong correlation between the introduction of DDT and the thinning of eggshells in sparrowhawks. The thinning eggshells interfered with successful reproduction, causing the bird populations to decline. But the data on eggshell thinning is a correlation only. Data on the actual molecular mechanisms of eggshell thinning under DDT is not known. As well, DDT does not appear to have the same effect in all bird species. Interestingly enough, with the ban of DDT in 1972 in the U.S., peregrine falcon populations began to increase. Again, a correlation. Again, a similar increase was seen in Canadian raptor populations following the ban of DDT in the early 1970s. But as the Western world banned DDT and the UN pushed all countries worldwide to ban DDT, the question is, wouldn't DDT kill mosquitoes that transmit malaria? Could DDT use prevent deaths from malaria? So what happens to the number of malaria cases if DDT is banned? Sure enough, as soon as DDT spraying stopped, the number of malaria cases increased. In Bolivia, Paraguay, and Peru, as DDT spraying stopped, malaria increased. And in Ecuador, as DDT spraying increased, malarial cases dropped. In Brazil, the more houses that were sprayed with DDT, the less malaria occurred. In Brazil, once DDT spraying stopped, cases of malaria increased. Malarial death rates increased in sub-Saharan Africa after the ban on DDT was initiated in the early 1970s. In 2006, the UN reversed its policy against DDT. The United Nations Health Agency started promoting the use of DDT to fight the global scourge that kills more than 1 million people every year, including around 3,000 children every day. The scientific and programmatic evidence clearly supports this reassessment. Indoor residual spraying is useful to quickly reduce the number of infections caused by malaria-carrying mosquitoes. DDT use continues to be used in LEDCs to combat mosquitoes that transmit malaria. DDT use continues to be used in LEDCs to combat mosquitoes that transmit malaria. But DDT is not the only weapon against mosquitoes that transmit malaria. Mosquito nets are equally effective and have become one of the most important weapons in the fight against malaria. Hopefully, at this point in the movie, you have full control of these syllabus statements. Describe the anti-malarial and agricultural use of DDT. Evaluate the uses of DDT. Dichlorodiphenyl trichloroethane, DDT, exemplifies a conflict between the utility of a pollutant and its effect on the environment. So DDT is a pollutant in that it has been correlated with the decline of certain bird species. DDT appears to accumulate in tissues, then magnify through the trophic levels. But it's a useful pollutant in that it kills mosquitoes that transmit malaria, thus reducing the incidence of malaria worldwide. Now take notes here. Get the details straight. Do you understand the statement where DDT exemplifies a conflict between the utility of a pollutant and its effect on the environment. Let me head toward the end of this movie by saying that there is a strong relationship between the funding to fight malaria and the global deaths due to malaria. And this includes the use of mosquito nets, seen here as the red line. As the use of nets in a Tanzanian village increases, the number of malarial deaths to children under 5 decreases. And that brings us to the end of IBESS, Atmospheric Systems and Pollution Management, Part 10.